Welcome back to the class on electrical machines 2. In this lecture, we are going to calculate the voltage regulation of a synchronous generator. In this method, we are going to conduct a OC and a SC test on a synchronous generator. OC test is nothing but open circuit test. SC test is nothing but a short circuit test. First, we are going to see the open circuit test. This is a circuit diagram to conduct a open circuit test as well as short circuit test on a synchronous generator in a synchronous impedance method. This is the stator in which the three-phase winding is there, which is connected in a star. So finally, we got a three terminals. Across any two terminals, we connected a 1 voltmeter. The three terminals are connected to the ammeter to the TPST switch. Synchronous generator also consisting a field winding. For that field winding, we had applied DC voltage. The DC voltage we are applying through the TPST switch, variable resistance, ammeter to measure how much current is passing through the field winding. So one more important parameter is that we have to give the mechanical input to the synchronous generator. In this case, how we are going to give the mechanical input means by means of a DC motor. The DC motor is mechanically coupled to the rotor of a alternator. So whenever the motor is rotating, the rotor also will be rotating on which the field winding is placed. This is the circuit diagram for the DC motor. This is the armature A dash. This is field winding. The field winding we kept a one rheostat, 3-point starter to start the DC motor. Here we kept a 1 voltmeter to measure the how much voltage we are applying to the DC motor. This is the DPST switch. Here we have taken the 230 volts DC voltage. Initially, we are going to conduct a OC test. So, we have to open this TPST switch. Again, here the DPST switch also the open. Nothing but we are not applying any voltage to the field winding. Close this DPST switch. By means of 3-point starter, we have to start the DC motor. By means of a field rheostat, we have to adjust the speed of a motor, which is same as the speed of alternator to the rated value. Once you adjust the speed of alternator to the rated value, then you note down the reading of voltmeter. Because we are not applying any current through the field winding, this voltmeter reading will be 0. Now you close this DPST switch. By gradually decreasing this resistance, increase the field current from 0 to the rated value. At every value of the field current, you note down the reading of this voltmeter. In this manner, you take the 10 to 12 readings of a field current and corresponding this voltage. So what are the voltage we are getting here is the line voltage, but we want the phase voltage, so we have to divide by root 3. We are getting the phase voltage. Here this is the table, this is the field current, this is the open circuit voltage. In this table, by varying the field current, you note down the voltmeter reading here up to the 10 to 12 readings. Now we are going to conduct a SC test. To conduct a SC test, once you conduct a OC test, then we can easily conduct a SC test also. So first of all, without disturbing the speed of alternator, you decrease this field current. So whenever we are decreasing this field current, then this voltage also will be come to the 0, but the alternator will be running at a rated speed. So whenever we are decreasing this current, this voltmeter reading is come to the 0 where field current is 0. Now close the TPST switch. So whenever we are closing the TPST switch, nothing but we are short circuiting the armature winding through the ammeter. Now gradually increase this ammeter, gradually increase the field current. At every step of the field current, you note down this ammeter reading. You can increase the field current up to the ammeter reading is equal to the rated current of a alternator. Then you can stop the test. Now you have to take the one more table during the SC test, serial number, field current and short circuit current. So in this manner, we are going to take the 10 to 12 readings. Now we have a two tables, one is the OC test, one more table is the SC test. If we observe these two tables, the field current is common. So now we have taken the field current on the x-axis. From the OC test, we have a data of open circuit voltage that we have taken the y-axis. If we draw a graph, we are getting the OCC curve of a synchronous generator. The same manner corresponding the field current, now you take the short circuit current on y-axis. You draw a graph means we are getting the one straight line which is passing through the origin. Now this is the linear region of a OCC. This region is nothing but a saturation region. In the linear region, one particular value of the field current, you find out the open circuit voltage and short circuit current. Now the synchronous impedance is defined as a ZS equal to open circuit voltage by short circuit current at a constant field current. So from this graph you are getting the voltage as well as the current, those values you have to take here. You are getting the synchronous impedance. Once you got the synchronous impedance, synchronous reactance equal to square root of ZS square minus RA square, where RA is nothing but a armature resistance or stator winding resistance. You can measure the stator winding resistance directly by keeping a multimeter across any two terminals. These two values are nothing but a per phase values only. So when you're going to take the voltage on the y-axis, you have to take the per phase voltage, not take the line voltage. Now once you know the synchronous impedance and resistance of the stator winding, then we can find out the induced voltage E0 equal to V cos theta plus IA RA plus V sin theta plus or minus IA XS. Here we know the V value, we know the RA value, XS value also. Suppose if you want to find out the voltage regulation at a off load, then you have to take the armature current at off load. Suppose if you want to find out the voltage regulation at a full load, then you have to take the armature current at a full load. So depending upon at what value of the load current, you have to calculate the voltage regulation. That value of the current you have to take in this. Next, power factor. Generally the power factor of the load also will be given in the numerator. So we can easily find out the excitation voltage or induced voltage or no load voltage in a stator winding at any value of the load current and power factor. Once you know the E0, then voltage regulation is defined as a no load terminal voltage minus terminal voltage at full load divided by the no load terminal. The no load voltage is nothing but E0. The terminal voltage at a full load, that is given in the nameplate details of a synchronous generator. You can find out E0 minus V by E0 into 100. Make sure that all these values are per phase values only. Where E0 is nothing but a no load terminal voltage or excitation voltage in synchronous generator, V is nothing but a terminal voltage at a full load. In this manner, we can find out the voltage regulation of a synchronous generator at a full load. If we want to find out at off load and a 3/4 load, also we can find out by using this method. In this method, by conducting OC test and SC test, we are finding only the synchronous reactance of a stator winding. RA value are calculated separately by means of a multimeter or by using a voltmeter method. Thank you very much. If you have any doubt, you can ask me directly or you can ask in the comment box of my YouTube channel, so that I'm always welcome to answer all your questions.